Hello, let's continue our lesson on differentiation. Okay, and today we are going to look at higher derivatives. All right, so if I have a function in terms of a function y and y is in terms of x, okay, then the first derivative, okay, as I have dy dx, that will be the first derivative. I can further differentiate the what? The dy dx, okay, and then after I differentiate, I can further again differentiate. So that is what we are going to look at. Okay, the first derivative. When I differentiate again, it is the second derivative. When I differentiate again, the third, the fourth, and so on. All right. So let's say if I have a function y, and then let's say y is in terms of x. Let's say as plus b. Let me say my y is in terms of x like this. All right. So this is a function of y in terms of what? In terms of x, where a and b is constant. Okay, so if I want to differentiate this particular function here, which is y, which is as plus b, you know, right, dy on the x. But how come the dy on the x? So I can say d over the x of the function of what? Of the function in terms of y. Okay, so if I write d on the x of y, then it means that I am differentiating what? The function y, which is ax plus what? Plus b, or that can be written as d over the x of ax plus b. All right, because ax plus b is the same as what? Is the same as y. All right, so if I write this, then it means that I am differentiating what? This particular function, and the result is what we see. We write what? dy on the x. So if I'm writing dy on the x, then the dy on the x, I am writing the final answer on the differentiation of this. But if I write d over the x on this, then it means that I'm going to differentiate this particular what? This particular function, and the answer I'll write for this will be the same as this one. Okay, so let's see what is happening here. So if I write d on the x of y, then that is the same as so d times y will give me dy on what? The x. And this is the first what? The first derivative, okay, of the function y with respect to what? With respect to x. So this is the first derivative. Okay, so if I want to further differentiate this, then that can also be what? D on the x, and the differentiation of dy on the x, and this can be written as d square y over the x square. Okay, and this is what? The second derivative. Okay, the second derivative. Now if I have a function, I differentiate and I further differentiate, that is the second derivative. So d on the x of dy over the x is d square y on the x square. So please don't write as d square d square x square. No, it is d x square, but the top is d square y over the x square. Okay, you want to get your third derivative, then that can also be d on the x, the differentiating of the second derivative, d square y on the x square, and that will give us what? The cube y on the x cubed. And this is the third derivative. This is the third derivative. So it will continue and continue and continue. And note how we write it, okay? Here on the s, d square y over the x square. Okay, so in the second derivative, it is the d square over, and then here to the x square. In the third derivative, the d cubed, and then here is the x cubed. All right. If I go to the fourth derivative, it will be d exponent 4y over d x exponent 4. That is how it will be. Okay, so as we continue to differentiate and different, this is how what we are going to get. All right, so let's take note of this. Let's take it, for instance, if I have let me say quadratic. Okay, if I have a quadratic, if you differentiate quadratic dy on the x, the quadratic will become linear. Take note of that. So 2 multiply here to give me what? 2ax plus, then this one give me b, and then the c will be 0. Okay, so a, b, and c, we know they are constant. So 2 multiply a, 2as minus 1, so it will be 2as, and then remaining the b here, and then the c becomes 0. So the differentiating of a quadratic gives a constant, a linear equation. And then if I further differentiate, the square y over the s squared, okay, then if I further differentiate, I'm going to get what? 2a, okay, so this will be 2a, and then here will be 0. So we know a is constant. So if I further differentiate, okay, the linear, I'm going to get what? A constant. And if I further differentiate the constant, it will be 0. All right, so if you further differentiate the constant, take note that you are going to get what? You are going to get 0. All right, so as you are differentiating a function, okay, and into higher, the first, second, third, into higher derivatives, what you have to take note is that the exponent will be reducing. All right, so if it is cubic and I differentiate, I get quadratic. I further differentiate, I get linear. I further differentiate, I get a constant. I further differentiate, it becomes 0. If it is exponent of 5, differentiate. The first derivative, you get exponent 4. The second derivative, you get exponent what? 3. The third derivative, you are going to get exponent what? 2. The fourth derivative, you get linear, exponent 1. And then it becomes constant, it becomes 0. Alright, so take note of that. Then, what we have to also take note again is that, you know, I can write my function f of x. Let's say it will also be equal to ax plus b. All right, if my function f of x, we know that the first derivative is what? F prime of x. Okay, then if this is the first derivative, then the second derivative f prime of x. Okay, this is the second derivative. The third will be f prime of x prime, so the prime will be 3. That is the third derivative, and so on. All right, so when you also see this, it is the same as the first, the second, and then the third. F of s is the function you are giving. When I differentiate, the same as f prime of x, f prime of s, f prime of x, the third derivative. So the first, the second, the third, okay, and then and so on. So this is how you can also write it in terms of the function. All right, so we are going to solve some examples right now. Okay, so let's look at the questions. Given that y is equal to x exponent 4 minus 1 over x exponent 3 plus 2 over x, find a dy over dx, b d square y over dx square, c d cube y over dx cube. Okay, so the first, the second, the third. Okay, so we are given what? Y to be equal to x exponent 4 minus 1 over x exponent 3 plus 2 on x. All right, so a, we are going to find dy on dx, but before that, okay, to be easy for us, let's bring the x to become a numerator. All right, so that's so y will be equal to x exponent 4 minus x exponent negative 3, so here is 1, okay, plus 2x exponent minus 1. Okay, so we have to take note that when this one comes, it becomes negative. All right, so a our dy over dx. Okay, so this one gives us what? 4x cubed. So minus 3 will multiply the negative on it to be plus what? Plus 3x negative 4. You subtract 1 from here. Then minus 1 multiplied to be minus 2 x exponent what? Negative 2. Okay, so 4x cubed, then 3 will come here, to multiply negative to be plus 3. X, you subtract 1 from it to be negative 4. Negative 2 negative 1 multiply 2 to be negative 2. Then x, you subtract 1 from here. So our dy on the x will be equal to what? 4x cubed plus 3 on x exponent positive 4. When it comes down, minus 2 on x exponent what? Negative x exponent positive 2. X exponent positive. So when we differentiate this is what we have. 4x plus 3 over x exponent 4 minus 2 over x exponent what? X exponent 2. Alright. So now let's come to the b. We go to the second derivative. Okay, so the b is the square y over the x squared. Okay, so I'm going to further differentiate this. Okay, but we know that if it is like this, if it is written like this, that is where the differentiation will be simple, because this is the same as this. So I'll because here the x is written as a numerator. So 3 times 4 will give me what? 12. Okay, then x exponent 2. Then minus 4 multiply the 3 will be what? Minus 12. X exponent minus 5. Alright. Okay, then minus 2 multiply the 2 here to what? Positive 4. X exponent minus 3. Alright. So let's see. So here 3 4 12. Then x minus 3 minus 1 give me 2. Then minus 4 times 3 will give me what? Minus 12. Then x minus 1, that is minus 5. Then minus 2 times minus 2 will give me positive 4. Then x exponent negative 3. So I can write this as what? 12x squared minus 12 on x exponent positive 5 plus 4 on x exponent positive 3. So when I further differentiate, this is what I can get. This is what I can get. Alright. Let's see is what? The cube y over the s cube, the third derivative. Okay. So the third derivative, differentiating in this way will be simple for us, where the x is written as a numerator. So 2 times 12 will give us what? 24. Alright, so 24x 24x, and then minus 5 times minus 12. Then minus 5 times minus 12 will give us what? Positive 60. Then x exponent negative 6. Alright, then minus 3 times positive 4 give us minus 12 x exponent minus 4. So let's check again. 2 times 12 will give me 24 x, so minus 1. Then minus 5 times minus 12, minus 5 times 1 will give me positive 60. Okay, and then x exponent minus 5 minus 1 minus 6. Then minus 3 times 4 will give me what? Minus 12. Then minus 3 minus 1 minus 4. So this can finally be written as 24x plus 60 on x exponent 6 minus 12 on x exponent 4. Okay, so this is about the higher derivative. The first derivative, and then the second one, and then the third one. Alright, so I know this is very simple to understand. Let's go to the question 2. Question 2. So y is equal to s exponent 4 minus s cubed plus 4x minus 1. Okay, find the square y over the s square and state the set of values of s for which the square y over the s square is 0. So we are going to find this, and then we equate it to what? We equate it to 0, and then we find the possible values of x. But we are asked to find the square y, but that is the second derivative. So we have to find the first before we get to the second. So we have to find the x, the y over dx. So this will give us 4s cubed minus 3s squared plus 4. And this will be 0. So 4 will come here, this one minus 1, and then 3 will come here, 3 minus 1, that will give us 2, and then this will give us 4. Alright. Then we come to the square y over the s squared. We further differentiate this. 3 times 4 will give us 12 s squared minus 2, 3, 6 x. Then this will be 0. Alright, so we have 12x squared minus 6x. And the question said that we should state the possible values for which the square y over the s squared is 0. So we are stating the possible value of x for which this particular function here, 2s squared. So we say that if the square y over the s squared is equal to 0, then it implies that 12s squared minus 6x is equal to 0. Then what can we do here? We can factorize. All right, so we can factorize what? 6x will come out. Okay, so it goes here 2, so here will give us 2x minus 1 equal to 0. So 6s times 2x will give us 12s squared. So it's 2, and then 6s times minus 1 give us minus 6x. So either 6s is equal to 0 or this is equal to 0. So it implies that 6x is equal to 0. If 6x is equal to 0, that will be 0 divided by 6. X will be 0. Okay. Or 2x minus 1 is equal to 0. Which implies that 2x is equal to 1. And then x will be equal to 1 over 2. So our possible values of s is 0 or 1 over 2 if the square y over the s squared is equal to 0. So we are saying we should find the set of values. Okay, so we can say that for the set of values is equal to s is such that s is equal to 0 or 1 over 2. Put it in a set form like this. So either s is 0 or s is 1 over 2. I believe this is understood. Alright, so simple with a higher derivative. I will see you again in our next lesson. Bye bye.